Hello and welcome back. In the previous video, we saw that what is a sigmoid function, and now in this video, we are going to understand quickly that why it is useful. This is useful because it provides a smooth transitioning. The sigmoid function provides a smooth transition between off and on, right? Between something to happen or not to happen, right? Allowing the neuron to gradually increase or decrease its activation. So based on that value, like its likelihood to happen or not to happen, based on that we just decide a threshold value that yes, this should be my threshold. If something is like not likely to happen, then in that case we are not going to fire the neuron. And something is like it's going to happen, it's more likely to happen, then in that case we are going to fire the neuron. And if we are sure that yes, it will happen, right? This is something to happen. Like for example, we took the example of a spam mail training, right? Training a model for the spam mail. Then in that case, if we are very sure that yes, based on the this particular word or this particular phrase, this must need to be identified as a spam mail. Then in that case, we are taking it as a activation, right? The neuron will fire in that case. Okay. The binary classification in the scenarios where you have the situation that you have to take a decision, binary decision, whether this will happen or not. But yes, there is a component of likelihood has also been associated. Then in that case, in such kind of binary classification situations, you will use the sigmoid functions. Okay, the output close to 1 can represent yes, yes, it's a cat. For example, there is a example given here, whether an image is a cat or a dog. The output close to 1 can represent yes, it's a cat, and the output close to 0 can represent 0, no, it's not a cat. So in essence, the sigmoid function is likely a smooth, gradual dimmer switch for neurons, helping them to make decisions and represent information in a continuous way. Okay, so mathematical choice of a sigmoid function. So this we have already discussed in the previous video. Here I have included that example as well, like email spam detection. So I hope I don't need to explain it again. Okay, so based on the previous explanation, I can just summarize it. I have written it here. These are my notes, and you will not be able to find it on any website over the internet, or there is nothing available around this because these are totally my personal notes. So just to prepare the videos, I have taken these notes. So imagine you are teaching a computer to identify spam emails. You give it as a bunch of emails, some labeled as spam and some as not spam. The computer learns to recognize patterns in the emails, like the use of certain words, phrases, or email addresses. So sigmoid rule comes here. The computer uses the sigmoid function to give the probability score to each email. A score close to 1 means the email is likely a spam, and a score close to 0 means the email is very likely not a spam. So in simple terms, sigmoid helps the computer express its confidence in its prediction. It is like the computer saying, I am not 90% sure that is a spam, or I am only 10% sure this is a spam. This helps the system make more accurate decisions about which emails to flag as spam. Okay, so let me iterate the last one as well. Dictate the last one as well. While the sigmoid function has been widely used, it has some limitations, such as vanishing gradients. So we are going to understand about the gradients in the coming videos. You can just understand the gradients as the rate of change. Okay, so what is the rate of change in case of straight line, or if there is a linear relation between the input and the output variable, then there is a straight line. And in case of straight lines, to find out the rate of change, you have to find out the tan theta, which is the gradient, right? You must have understood that in your college days when you were understanding about the straight line equations. Let me show you. So gradient is nothing like this is from the previous video, and let me show you the gradient. What is gradient? Gradient means rate of change. I mean how the values are changing, right? So if there is a linear relation like y is equal to 2x plus 3, right? In that case, what will happen? This will be a straight line, right? Plus 3 means the intercept on the y-axis, so it will be something like this, right? So if this is twice x, y is equal to twice x, then in that case, if you have to find out the rate of change, then obviously you will just find out the theta, that how the values are changing, right? So you will find out the theta. Okay, so you will find out like y2 minus y1 upon x2 minus x1, like how with each of the points, the value is changing, and based on that, you will find the you know angle and the rate of change, right? Suppose if you are taking it as like y is equal to x, then in that case, what will happen is like it will be changing like with every line, with every x1 and y1 value, you will find the result as 1. This tan theta or m, you will find it as 1 every time if the equation is y is equal to x. Okay, because it will be like if x is 1, y is 1, so you will find here x is 2, y is 2, so you will be something like this, so it will be making a 45-degree of angle, and that's how you know that tan 45 is equal to 1. You know this, right? So this is how you find out the angle. But in case of a curve, this is the straight line, so very simple. In case of a straight line, this is very simple. You just have to find out the tan theta, and if tan theta is 1, then obviously you know it is 45-degree, means uh, the equation will be y is equal to x. There is a simple linear relationship. But in real life scenarios, the two variables, the input and the output variables, specifically when we are talking about the machine learning and data science, then in that case, if you will see the data, there is not a linear relationship. There will be some kind of curve. For example, this is a curve. In the last video, we saw the sigmoid curve. Let me draw it properly. It is not drawing it properly, so let me do like this. So this is like this. Okay, so this is the curve. Like, so here, if you have to find out the rate of change, then this is a curve, not a straight line. So how you will find it? So what we do, we simply find out a small area, a small change. So we make it like delta y upon delta x. So what we do, like here, we find out a small area like this, and here this small area will give me the derivative, like how the values are changing. These derivatives we find with the help of the differentiation. That's why we do the differentiation. ddxy, ddxy, ddxy. This is the differentiation. So we are differentiating y. We are trying to find out how the y is changing with a small change of x, right? So it is something like you had a curve, something like this, and you want to find out like how the value is changing, how the curve is changing its value, how the curve is changing itself. Then so in that case, you just need to find out a small y-axis and a small x, right? Both the axes you need to create here, so that you can find out a very infinitesimal x and y here, right? And after that, you will be find out the rate of change, ddxy. This is called the derivative, and this is the rate of change against a curve. So this rate of change against a curve, this is something which comes under the calculus, and this is where the calculus is used in the machine learning models, specifically in the artificial neural networks. Okay, so I hope you must have understood this. So let me let me show you, like here, if you see, it has been written the same thing here. Problem is like sigmoid functions has widely used. It has some limitations such as vanishing gradients, means the rate of change will stop at some point of time, right? Because at on this point on the top, it becomes after that there will be no rate of change. It will be like uh, you know simple straight line. So 180-degree. So tan 180-degree, you already know it's 0. So you will not be able to find out the rate of change. I mean, this is not always the ideal situation. I mean, even if you are identifying a spam mail, then this is likely to be a curve, right? This is likely to be a curve. But if this curve is not like this, it could be something else as well. Then in that case, if you are not able to find out the best of the results using the sigmoid function, okay, if you are not able to get the best of the results, you are not able to train the model properly with the help of the sigmoid functions, because the gradients are vanishing at some point of time. After that, what you will do in that case, you may need to find out a particular curve which is not like this, which may be having some other kind of scenario where you must need to consider after beyond the point where the gradients are vanishing. So in those cases, there is another function available which is known as the ReLU. This ReLU function is used as an activation function. Okay, for other situations. But yeah, mostly in case of those situations where you have to find out where is some kind of likelihood is involved, okay, for any event to happen, then in that case, we usually do use the sigmoid functions. But yeah, based on the sigmoid ReLU function, you choose one of the methods. If you are not getting best of the results, you choose another method. You choose then PANH method, right? So any activation method you can use based on your results, based on your accuracy, because there are certain functions which gives you the accuracy, F1 score. All these we will be understanding in the coming videos. But yeah, as of now, in this video, that's it for today, and we'll meet next video with the understanding of ReLU. We will understand what is ReLU activation function. Till then, have a nice day and bye bye.